In this lesson, we'll talk about factoring polynomials. So factoring is a technique that takes a lot of time to get practice, and this is intended to be a review of the factoring that you did in earlier classes. So hopefully it all comes together for you, but if you need additional practice, please take the time to do this as well as you can. You want to be decently good at factoring in this class and in future math classes. It comes up and comes up and comes up. Anyway, if you want to factor a polynomial, what you want to do is try to undo the FOIL method. It's almost a type of reverse FOIL. You want to find two expressions that if you were to multiply them together, you'd get back to what you have at the beginning. So we've got some ideas here of factoring completely. Sometimes if you factor once, you can factor even more. And then sometimes you'll run into things that just can't be factored any further, and we often call those prime. Similar to a prime number. A number being factored just means finding two things that multiply to make the number, but a prime number only has one way to do it, one in itself. The same thing happens with polynomials. You really could only factor it to one in itself. Alright, so let's go through 4 different methods of factoring. The first one is just the greatest common factor. This is the one that is the easiest one for you to do and the easiest one for you to forget. It's amazing how many students will try to do these, but just forget that this technique even exists at all. So, never forget that you can just factor out something sometimes. For this particular one, I'm looking at my numbers, and I see that a 4 can be factored out of each number, and it doesn't appear that anything bigger than 4 will factor out of all 3. So I'll start with 4. And then for the y's, I see a y to the 6th, a y squared, and a y to the 5th. And I'll give you a little tip. If you're deciding what you can factor out, take the smallest power that appears among the terms, because you can't factor out anything bigger than that from, say, this term. So I factor out a y squared. And then all we're really doing is seeing what's left if you were to multiply them back together. It's type of a division in some ways. So 12 divided by 4 is 3. And then what would have to remain to get the y to the 6th? Y to the 4th. You're basically subtracting your exponents. Next one, if I take the negative 8 and factor out a 4, I get a 2. And the y squared factors out completely. So we're done. Next, with the negative 16, if I factor out a 4, I get negative 4. And the y to the 5th, when we factor out the y squared, we get y cubed. So that's what it looks like if we take out a greatest common factor, and we'll leave it there. Alright, let's move on to the next one. So for this one, we can certainly factor out a 3, and it looks like we can also factor out an a of some kind. I see an a squared and an a cubed and an a squared, so the lowest power is the square. We'll take that out. Then we've got a b and a b and a b squared, so we'll take out the b. Now that leaves us with a peculiar situation. I'm factoring out the entirety of the first term, but it doesn't leave a 0 behind. Remember, this is kind of like division, and when you divide a number by itself, you get a 1. Next, the 3 factors out, the b factors out, and if I take a squared out of a cubed, I'm just left with a. Next, if I factor the 3 out of negative 9, I get negative 3. Factoring the a squared out leaves nothing behind, and factoring a b out just leaves a b. And that makes this one finished. Next method. This method is called factor by grouping. Factor by grouping is a very handy technique when you have 4 terms, and I'll show you another time when you can create 4 terms from 3, and factor by grouping helps your process along also. So the method of factor by grouping is as follows. You group out the first 2 terms and the last 2 terms, but there's a very important thing that you need to watch out for. Write this as plus a negative if there's a minus. When you use factor by grouping, you must have a plus between your terms. If you don't, you're likely to mess up. So now what we do is we factor out the greatest common factor out of each term. So for the first one, I can factor out an x, which leaves me with a minus 2b. Now the second one, if this value is negative, it's a good idea to go ahead and factor out a negative. So I'm going to factor out a negative, and I can take out a 2 and also a y, which leaves me with a minus 2b again. The negative coming from the fact that if this was positive and I factor out a negative 2, I'm left with negative 2. Now, the way to know if you're successful is by looking at the two remaining factors. If they match, you have not made a mistake, more than likely. If they don't match, you need to go back and check your work again. It might be possible that the polynomial cannot be factored by grouping, but it's always something that you should check for. So anyway, the final answer is take the coefficients, and I'm going to write it as x minus 2y. That goes in as one factor, and the common one is the other factor. Now a question I often get is, why doesn't the a minus 2b show up twice? So let me give you a little tiny picture of this. Let me write it like this. If I replace a minus 2b with just this character z, then you should be able to see pretty well that if I factor out the z, it would look like this. Even though it shows up twice, when you factor things out, it comes out to be only once. So if you look at the x minus 2y times z and you put the term back in, this should make perfect sense why the factor that shows up twice ends up only showing up once in the final answer. So again, the first factor is the coefficients, and the second factor is the one that's common to both. Let's try this one again on the next example. So again, you put parentheses around the first two and the last two, and make sure that this sign is a plus. If it's not, you should say minus a positive becomes plus a negative. Anyway, we didn't have to deal with that in this example. So for the first term, I can factor out a z, which leaves me with 1 plus z. And in the second term, I can factor out a 2, and I can also factor out a z cubed, which again leaves me with 1 plus z. So, since these two numbers match, we are exactly where we want to be. I get z plus 2z cubed times 1 plus z. Now, this would be kind of nice, but there's actually a tiny bit more that we can do. If we want to factor completely, you'll notice one of my factors still has a z in it. So I'm going to write this as z times 1 plus 2z squared. I'll factor the z out, and then I get 1 plus z. So this is a little bit more simplified than the previous one. Alright, so there we have it. The next method is the special factoring rules. So the first one is one that you need to know. You need to be able to recognize and use this rule, not only in this class, but in future math classes also. This first rule is called the difference of squares factoring, and you need to recognize when you see it. Simply put, if you have one thing squared minus another thing squared, then you write it as that thing plus the second times that thing minus the second. Let me show you by example what I mean. So this is a square of a specific term, 3x. So if I were to square the 3, I get 9, and if I square the x, I get x squared. Something similar happens here. 16 is 4 squared, and y to the fourth is y squared. It's kind of like I just divided the power by 2. So as long as these powers are even, and these numbers are perfect squares, I can use this method. So simply put, from here, this is my a, this is my b. So I have a plus b times a minus b. And again, you need to be able to use this formula. This formula will get you through the problem. in the times that you really just don't see any other way to factor it. The difference of squares is a nice formula. And it comes down to the fact that when they do have just a sign difference here, the inner term and the outer term, if multiplied out, will cancel each other out. Next, we got these difference and sum of cube rules. Now they're kind of similar to the difference of squares, but the formula is a little bit more complicated. So I'll tell you how I remember it, but I do plan to give this formula anytime that you do not have your own notes. So a cubed minus b cubed. You'll notice for both of these formulas, the first term is just a and b, and it keeps the sign of whichever term you're starting with. And then you've got a squared plus the product plus b squared. And you'll notice that this sign is the opposite of the sign that you started with. And that's how I keep these formulas straight. So this sign for the second term here should be opposite the sign that you started with. And the first term, the sign should be the same as the one that you started with. So here's some examples. This first one is a difference of 2 cubes. So 8 is 2 cubed. And x cubed, I'm just going to have the x. And then y to the 6th. We want to write that as something cubed. Well, if you needed to multiply the powers, it would be y squared cubed is the y to the 6th. So we apply our formula. If this is my a and this is my b, remember for the first factor, I keep the sign. And for the second factor, I do first term squared. This is the opposite sign here, so plus the product, 2x times y squared, plus the last term squared. So this is my formula. I get 2x minus y squared times 4x squared, squaring each term, plus 2xy squared plus y to the 4th. And that's how I tackle sum and difference of cubes. Alright, next problem's for you to try. So hopefully you've got the sum of cubes formula handy. See if you can give this one a try. Alright, hopefully you did pretty good on this one. If not, feel free to pause at any point and try to finish my work. We see a sum here, and x to the 9th, if you were going to have to multiply your exponents, the only way it could be 9 is if this were a 3. X cubed cubed. And then 27 is 3 cubed. So again, the formula is keep the same sign for the first term. And then we've got the first term squared. This time it's minus the product because it's the opposite, plus the last term squared. And then let's just simplify it. So we get x cubed plus 3. Then multiplying my powers, I get x to the 6th minus 3x cubed plus 9. Hopefully you did pretty good on that one. And then the final approach. This is the approach that's the most common technique as far as factoring trinomials. And the first 3 should be pretty easy. The last 2 that we're going to do on the next slide, I'm going to show you a little technique. But if you have a technique that works for you, such as trial and error, you should stick to that technique, whichever one is fastest. So, for these, what you want to do is look at the coefficient, the leading coefficient. If it's just 1, then all we have to do is find 2 numbers that multiply to the last term and add to the middle coefficient. So again, multiply to 6, add to negative 5. What 2 numbers do that? Multiply to 6 and add to negative 5. If you said negative 2 and negative 3, you're right. So this is how we do it. X minus 2 times x minus 3. They multiply to positive 6, but add to negative 5. That's how you do it. Next example. They need to multiply to negative 18 and add to negative 3. So we would expect one to be positive and one to be negative, and they have to multiply to negative 18. Which two numbers do it? If you said 6 and 3, you're right, but which one's negative? Well, since they add to a negative value, you're going to have to use the 6 as your negative value so that the whole thing comes out negative. So again, they multiply to negative 18 and add to negative 3. Here's the final one. They multiply to negative 15 and add to positive 2. Which two numbers do that? Well, if you said 5 and 3, you're right. And this time the 5 is positive because the 2 is positive. And there you go. Here's the final one. Now, sometimes you run into some problems that are a little bit harder, so that this number in front is not a 1. When this happens, you can either use a trial and error method, or you can use something called the AC method. Now, there are two other methods that I'm aware of, and one of them is a sort of trial and error mixed with AC, and one is called the fast AC method. So if you're interested in hearing about the fast AC method, it is the fastest way to do these. The problem is that understanding the fast AC method isn't difficult, but it is rather mysterious. And it is the best way to factor if you want to do it quickly. The only way that I know of to do this faster is if you learn the AC method and learn how to use it with trial and error. That's something that I can show you another time. Anyway, I'm going to show you the AC method. So if you recall correctly, in a quadratic equation, you've got A, B, and C. A, B, and C are your coefficients. And so for the AC method, you compute A times C. So 6 times negative 6 is negative 36. And what we do is a similar process. We find two numbers that multiply to this value and add to 5. And so those two numbers in this case are negative 4 and positive 9. Here's the technique. What we're going to do is we're going to split the 5x using these two numbers as the coefficients. We get 6x squared minus 4x plus 9x minus 6. And in doing so, we have created something with 4 terms. What we're going to do is we're going to factor this by grouping. Now notice I've got a plus in between. Remember that if you happen to have a minus, you need to be a little bit careful and write it as plus a negative instead. So in this one, I can factor out a 2x, and I get 3x minus 2. Second term, I can factor out a 3, and I get 3x minus 2. So the 3x minus 2's match as desired. If they didn't match, that probably meant that you messed up somewhere either in this process or perhaps in the factoring steps. So we get 2x plus 3 times the common factor of 3x minus 2. Now I'll give you a little tip. 6x squared I've split into 2x and 3x. And negative 6 I've split into 3 and negative 2. Notice that the inside and outside terms are 9 and negative 4. That's the same numbers. So if you can learn to harness this technique and try to find a pair so that these multiply to the first term, these multiply to the last term, and the inner and outer terms are these numbers, you can factor very quickly. That's the method that I use to try to do that in my head. Alright, next one. We've got 25y squared plus 10y plus 1. So again, do A times C. And I just get 25. So what two numbers multiply to 25 and add to 10? This one's pretty easy this time. It's just 5 and 5. So again, we'll split the middle term using these numbers as coefficients. So I get 25y squared plus 5y plus 5y plus 1. And again, we're going to factor by grouping. So I factor out a 5y, and I get 5y plus 1. Now in the next term, I can't factor out anything. So I'm just going to factor out a 1 and leave it be. Now we've got common factors that are the same. That's good. So we get 5y plus 1 are my initial coefficients, and the common term is 5y plus 1. Remember, factoring is a very important technique, so you need to make sure that you get decently good at it.